And now it's time for
Calculation Nation
with your host, Terence Campo.
Hello and welcome to Calculation Nation. This is the first episode of a new series where we're going to talk about the TI-83 calculator, TI anything really, and a lot of stuff that you can do with it. Stuff that maybe you didn't know you could do, or stuff that you don't really know how to do. Today we're going to be talking about sequences. We'll start out with a nice easy sequence. We're going to do our square numbers. We're going to just outside of this. We're going to make squares with our dots here. 1, 2, 3. And we're just going to examine these little diagrams for a second. There we go. Now, each of these pictures here makes a square, and they each contain a certain number of dots. This one contains 1 dot. This one contains 2, 4 dots, 9, and here we've got 16 dots. What's our good old 5 square? 25. Well, if we were to continue to make squares in this manner, well, these numbers would all follow a pattern. And it's our job to, right now, because this is a lesson on sequences, we're going to figure out what that pattern is. So to do that, what you want to look at is which number term this is. So let's look at this first square, the second square, the third square, fourth, and the fifth. And these, we're going to keep on going with these. Eventually we're going to get to the nth square. That's a generalization. That's going to be the square that we end on eventually. But to figure out what relation the nth square has to the actual number of dots in the nth square, we've got to compare these numbers. So 1 to 1, 2 to 4, 3 to 9, 4 to 16, 5 to 25. There's a pattern here. Eddie, do you see the pattern?
They're all square roots.
Yeah, they're all square.
That's right, Eddie. That's our special guest, Eddie. They're all square roots. So, if you take the number of the square, this is the first square, and we square it, we'll get the number of dots in the square. So, when we get to the nth square, how many dots will there be?
Depends on the n.
That's right, it depends on the n. So, there will be n squared dots. Okay. Pretty easy to figure out on hand. But, what if I want my calculator to figure out, oh, let's say, the first 10 squares for me. So, to put this sequence into the calculator, we're going to use our special button. We're going to go to Second, List. We're going to go over to Ops. We're going to go down to this SEQ. That stands for Sequence. That's number 5. Okay. Now, in order to enter a sequence, what you need to do is you put in first the general form of the sequence, which is our, right now, well, let's use n squared. That's what we decided. So n squared. Then we're going to put a comma. We're going to tell it, oh, what's the variable there? Well, we used n. Okay. So first the formula, the variable. Then we're going to start with the starting terms. That was our first square. And then we're going to go, I said 10 terms. So, then the stop. So, that's all we really need right now. Press enter. And there we go. We've got 1, 4, 9, 16, 25. Those ones, they all match up so far. And then if we keep pressing over to the right, we got 36, 49, 64, 81, 100. Ta-da! That's really all there is to it. Now, we go a little further, step. We go back to sequence. and we'll put in the same thing. N squared. N. And then we're going to from 1 to 10. If we do one more, this is the step. This is if I say I only want to do every other square number, then I put a 2, and it'll go up by 2s instead of by 1s. All right, close that. Try it out. See, we got 1, 9, 25, 49, 81. And really, that's all there is to it. So let's go back to the paper and we'll try a different sequence. Alright, now that we know how to do that on the calculator, let's try another sequence. This time we'll do triangular numbers. 2, 3, yep. There we go. So, we got it started. We got 1, we got 3, we've got 6, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Boy. If we keep going with this, we're going to have to figure out some kind of generalization, or some kind of pattern on how these grow. So what we got to do is compare 1 with 1, 3 with 2, 6 with 3, and 10 with 4. Because what we have here is the first term, the second term, the third term, and the fourth term. Let's take some time. You stare at it for a while. Eventually you figure it out. It helps to know the formula for an area of a triangle. So, what do we do here? So, what we're going to take is, we're going to look at our n. We're going to compare it to our formula here. And it does take a while to figure this one out, but basically you do n. We're going to multiply it by n plus 1 and divide that by 2. So here we've got 1 times 2 over 2, which will give us 2 over 2, or 1. Here we've got 2 times 3 divided by 2, gives us 3. 3 times 4 divided by 2, 3 times 2 is 6. Okay, so we want to figure out our first 10 triangular numbers. So we're going to go to second list, ops, down to number 5 sequence. We're going to enter in our new formula. We've got n times n plus 1. Oh, that wasn't an n. There we go. N times n plus 1. And we're going to divide that by 2. We're going to tell it the variable is n. We're going to go from the first triangular number to the 10th. And enter. 1, 3, 6, 10, 15, 21, 28, 36, 45, 55. And looking at the triangle numbers, every time we add a new triangle number, we start with the last one, and that's the 10, and we add another row. Each time you add a row, this time we added 2, 3, 4, 5, and when I looked at those numbers on the calculator, the next one was 15. They all did that. They followed that same pattern. So, if you have any ideas for next week's show, something you'd like to see on the calculator, please feel free to leave it in the comments section. Thank you for watching, and I'll calculate later.